Good morning, everybody. Welcome to this webinar by Marta Ellena, who will present her work on social vulnerabilities and extreme heat, aiming at transformative urban adaptation. It's a great pleasure for me to present her in this occasion. She's working on this argument since her PhD thesis, which she finished in 2022. And we have been working together in part of this activity, being inspired by inter alia, a work by Eric Kleinenberg, who has described the Chicago heat wave in 1995, and describing how the lack of preparedness in the city and the social differences in the conditions of social and economic differences of inhabitants led to a catastrophic outcome of a short heat wave of 10 days. More than 700 people died during this heat wave. And Kleinenberg describes in a very interesting way that both the institutions were not prepared, but also the conditions in which persons lived were contributing heavily to their risk of dying and to their survival chances. For instance, one thing which remained very much, which impressed us very much, was his description that in those areas where crime rates in socio-economically disadvantaged areas were rather high, old people died because they were afraid of getting out of their dwellings and looking for refreshment, because they were afraid of crime. So dealing with heat waves and vulnerability to heat waves is, and this is at the basis of Marta's work, is not only about high temperatures or levels of temperature, age and pre-existing health conditions, but it's also on socio-economic disadvantages and how the city is made and works. So I'm looking forward to her presentation, but before I give her the word, I would like to quickly introduce you to the context in which we are working, that is the CMCC, the Euro-Mediterranean Center for Climate Change. We are now existing since 20 years and are a research center which is very much working on the understanding of such interactions between climate change and society, working together with many international, European and international organizations, as you can see here, inter alia also with IPCC, Resources for the Future, and so on. And are very much based on modeling on the one side, advancing the work on climate models and the multidisciplinary analysis, combining this with impact assessment and environmental economics, so to support the science-driven adaptation and mitigation actions. We have three multidisciplinary research institutes, 4 strategic programs, a computing infrastructure, and specialized centers on digital innovation. The 3 institutions comprise different research divisions, of which Marta and myself are working in different research institutions. This one on Earth system predictions, which is essentially modeling on and the generation of predictive tools. It is the Institute for Climate Resilience, which is working on risk assessments in different divisions, and the European Institute for Environmental Economic Assessments, where Marta is working in this second one in the REMI division, and I'm myself working in the division dedicated to climate assessment of climate impacts. We have strategic programs, global interaction for biochemical and industrial carbon cycle, predicting socio-economic impacts, global codes, and integrating AI and machine learning in the modeling chain. These are some of the strategic activities undertaken. And have some very powerful computing and innovation centers. This to just give you a flavor of what the variety of activities are being undertaken in CMCC and the cross-disciplinary work we are undertaking. Some housemate, before I give the word to Marta and her presentation, some remarks on housekeeping. Audio and video are deactivated for you by default. If you want to intervene or ask questions, please write in the Q&A action while the chat will be closed. So this is all for my side, and Marta, please go ahead.
Yes, here we are. Can you see my presentation in full screen? Perfect.
Yes.
Thank you. So good morning, everyone. Thank you to being here and listening me and Margaretha today. And thanks also, Margaretha, for the very nice introduction about the work that we have carried out in these last years. So my name is Marta. I'm part of the Institute of Climate Resilience and also Predicting Socioeconomic Outcomes of Climate Change program. This presentation today will touch some very, let's say, interesting and nice topic related to the state of the art literature and our context that we are living in our cities, social inequalities and extreme heat, also touching what transformative urban adaptation is and where we are going, in which direction. So I just want to start this presentation touching these three main concepts that actually are shifting meanings based on the context we are considering. And actually these three concepts are also the base of this presentation of today and of my work carried out from my PhD until now, let's say. So the first one is the concept of urban. The definition of urban is based on national purposes, let's say. And in here, I just provide you some example. The first one is related to Sweden. In relation to urban context, Sweden referred to build-up areas with 200 inhabitants or more, where houses are at least most 200 meters apart. If we consider Japan, for example, cities are defined as shi, which refer to a municipality which satisfies three criteria, let's say. The first one is 50,000 inhabitants or more. The second one is 60% or more of the houses located in built-up areas. The third one is 60% or more of the population engaged in manufacturing. The last example that I decided to include here is related to the Zimbabwe. For Zimbabwe, the urban context refers to places with at least 2,500 inhabitants or more, whose population resides in compact settlements patterns, but at the same time, the 50% of the employed persons are engaged in non-agricultural occupation. So as you can see, actually, the definitions are refer to similar aspects, but with complete different, let's say, point of view. For what it concerns the second concept, the one related to heat waves, as you know, probably there is no formal definition and a standardized one definition of heat waves. The World Meteorological Organization defined heat waves are at least 5 consecutive days during which the daily maximum temperature surpasses 5 degrees Celsius or more. Some other the countries refer to heat waves also in this case in different ways based on the context, on the climate situation that they are, let's say, living. For example, the India Meteorological Department requires that at least an increase of temperatures of 5 or 6 degrees can occur above the normal temperature. And these are just, of course, some example in relation to what we refer to heat waves. Finally, the third context, that is the base also of this presentation, is the one related to the equality. That is a core concern in the today debates on social justice also. We can also refer, for example, to the context of just transition, looking at the international policy situation. I just want to raise here the fact that often there is a misunderstanding or among the concept of equity and equality, because they are quite similar among each other, but we refer to equality, therefore inequality, for this presentation, since equality emphasizes uniform treatment, while equity focuses on fairness of process and outcomes. So cities are the epicenter of the climate crisis. In fact, the population living in cities to date accounts around 55% worldwide. And at the same time, the people more affected, but also the system more affected by the impacts of climate change to date are the urban areas. And at the same time, they have the power also to change the quantity of the emissions that are released in the atmosphere thanks to the economic activities that characterize cities. The World Meteorological Organization, among others, cited clearly how the temperature in city can reach +7 degrees more in relation to the surrounding areas or rural areas. And this is also due to the fact to the, let's say, phenomenon called urban heat highland phenomenon, who is an already existing phenomenon across all cities due to the characteristic of the built environment, who, let's say, is the base of our built-up areas, and increase the heat stress during summer and can prevent the cold stress during winter. So this is the increase of temperatures that we can see in urban areas, especially in summer months. The UN Call of Actions 2024 called for a heat-proof urban environment so as to protect vulnerable population as much as we can. So this heat-proof concept, of course, relates to the climate-proof concept, but with a specific focus on heat. In 2024, we marked a turning point because we reached the hottest year on records looking at summer temperatures and summer month, with plus 0.69 degrees Celsius above the mean 1991-2020. When looking at the future, it was difficult for me to choose one specific infographic to show you, because there are many and they are very nice, because they can give you a clear perspective of how the urban population will increase in 2050. And in fact, you can see here in the graphic in the right part of the slide, the share of urban population as well as urban and rural, and of course you can see that the urban one will increase a lot in the future. And this, together with the urban heat highland phenomenon during the summer month, will amplify the extremes and also the risks over the urban population. Therefore, urban areas need to adapt growth and protect people in a transformative way. We will see this concept later on. By 2050, the people are 1/7 people are projected to live in urban areas, and with climate change, cities will face increasing risks. If we look at the plus 1.5 degrees Celsius increase of temperature, 67 cities may face over 150 days per year with temperature above 35 degrees Celsius. Therefore, we call it summer days. If we look at 3+3 degrees Celsius warming, this number of cities can increase to 197. And this is a huge, let's say, percentage of summer days over the all year. A very recent report about resilient city cited clearly how the challenges who face cities are mainly divided in 6 highlighted. Urban overexposure, due, of course, to the fact that a lot of people live in urban areas. Therefore, the economic and social life is much stronger in these systems. Therefore, the risks are much higher. Inadequate planning, inadequate planning, who refers to the fact that the rapid urbanization that we are facing, together with the unsuitable materials, can bring urban areas to face very strong risks due to the fact that the plan is not based on transformative processes, but is something static, and in many cases is not really aware about the risks that we are facing in relation to the different impacts of climate change. The third highlight is the fragmented governance. Therefore, responses are often uncoordinated and reactive, and these, of course, increase the risks that cities are facing. The loss of productivity, therefore, the 70% of the global workforce is exposed to extreme conditions, and this brings to a collapse in the productivity. If we are looking at external workers, this is, of course, much more obvious. But if we are also considering internal workers in offices that maybe are not in a proper condition to work, let's say, in an efficient manner. The fifth challenge is the public health at risks. Therefore, the public health sector, but in general, the health sector is extremely under a risk looking at heat and this increase of temperatures during summer. And finally, social inequalities. And this is also one of the main pillars, as I mentioned before, related to this presentation. In relation to social inequality, I decided to show you these plots that have been published in Chapter 8 of the assessment report of the 6 of the IPCC. And this is actually showing more clearly the inequality and climate change vicious cycles that we are facing. This is when a climate hazard occurs and there are limited opportunity to adapt. Of course, the productivity during like an extreme events such as heat waves decrease, as well as the outputs. And this brings to poor nutrition and low assets and security for the population, and the cycles go back to the poverty trap. At the same time, you can see in the right part another cycle that is still a vicious cycle. When a climate hazard such as heat waves occur and there are limited resources, the livestock and the crop losses is something that is very probable, and this brings to limited income generation streams and low level of human capital, and again back to the poverty trap. So this is the reason why also in the negotiation and in the IPCC, we are listening on the principle that the one who suffer the most are the one more at risks, also based on the resources that they have. I decided to show you here an index that I really like. It's called ND Gain Country Index Score, and this is the update of 2024. It is produced and updated by the Notre Dame University. And in here in the map, you can see clearly how like the global south countries are affected by red colors, orange colors, while in the northern countries are more related to greenish color, let's say. This index is based on two main indicators, vulnerability and readiness. And these two aspects are then divided based on different, let's say, factors that these researchers are considering in order to understand which is the readiness as well as the vulnerability of each country. As vulnerability, they consider health factors, food, ecosystem, habitat, water, and infrastructures, while for readiness, they consider social readiness, economic readiness, and governance readiness. Of course, in case you're interested, we can share the presentation and you have all the sources at the end of the presentation. This just to give you an overview about like the diversification of, let's say, the risks and the preparedness of the countries around the world based on the impacts of climate change in general. But if we look at inequalities across the scale, in here, in the left side of the slide, you see the diversification of the inequalities. This is a plot provided by Eurostat at NUTS 3 level. And this is interesting to see how much the inequalities can change within a specific country as well. In fact, it's very important to, if we have the opportunity, to go more in detail and see also at a more finer scale what is happening. The three plots in the right side of these slides are taken from a study developed in Rotterdam. And you can see the district scale resolution, the neighbor scale resolution, as well as the finest resolution of 2050 meters scale. And of course, if we have the opportunity to go more in deep about the resolution, not only the climate one, but also on the diversification of inequality, we can have a more clear prospect of how these inequalities distributes, but also how the risks is higher and where to act with priority in relation to adaptation measures. And in here, we pass to the core also of the problem that we are facing nowadays and we are treating in the discussion that is related to the access to easy and open access data. And in order to run this kind of analysis that we are going to present today, we need climate data from observation, climate models, and also satellite imagery to work with remote sensing analysis, demographic data that can refer to age, gender, or density, socioeconomic data, health data that can refer to hospitalization, but also mortality, for example, or pharmacological life, and finally, contextual data. And in this case, we can refer to indoor context, therefore, how our buildings are built inside, which kind of material, which kind of services we access to, and which kind of, let's say, offices we are using, but also outdoor context data, therefore the quantity of green, the quantity of trees next to us, the possibility to walk nearby a river, for example, and so on and so forth. Therefore, the open access data and the access to data in general is the base, of course, to run this kind of analysis over the context that can be from a national scale to a very fine scale. Our case study today relates to the city of Turin, that is in the northwest of Italy. And as you can see here from the map provided by the European Environmental Agency, the city of Turin is quite big and is located in an area where the trends in heat-related mortality incidents in the last, let's say, 20 years have been very high. One of the second reason why we pick up an Italian case study is not related to the fact that I am Italian, but is related to the fact that from a study run by Gasparini et al. Several years ago, it came out Italy holds the highest attributable fraction of mortality when considering extreme heat, where you see actually the yellow arrow. Among all these countries, actually. So this is quite impressive. The third reason why we pick up Turin and not another cities is related to the fact that Turin, thanks to a doctor called Giuseppe Costa, who led the health agency of the region, we are nowadays able to use the time series that they have available that brings data from the socioeconomic status to the demographic events, therefore like the demographic factors, but also the residential movement of the person within the city. And all these data are linked with health outcomes, and they start from 1971 until today. So this is a huge time series to use in order to see how like the inequalities can change and how much they are important in relation to, let's say, health. So these are mainly the four papers that we are going to go more in detail in the next slides. And they have been based on strong work made with different researchers in Ca' Foscari University, of course, CMCC, Barcelona Institute for Global Health, and the Regional Health Agency. The first one refers to a literature review in order to understand the context related to the nexus among heat and health, but also with the built environment characteristic and not only on social economic vulnerabilities of the population. The second one is a quantitative, it is using a quantitative approach to understand how the relative risks of mortality due to heat moderate, and extreme, is differentiated among the different, let's say, layer of the population. The third one considered all the time series divided in slot in order to see if the population of our case study have been able to adapt or maladapt in the course of the years. And finally, the last one, it is actually using another approach that is not based on statistical modeling, but it is based on the IPCC framework in order to make use of data that are available, but also to provide a framework related to the heat health nexus and risks evaluation that can be replicable to other contexts where the possibility to reach a richest time series is not so obvious. All these four, let's say, research articles touch four different SDGs, Sustainable Development Goals. Number 3, good health and well-being. Number 10, reduce inequality. 11, sustainable cities and communities. And 13, climate action. So the first article, as I was mentioning, was a review based on all the literature available, mainly in English. If I'm not wrong, we also considered 2 articles with Margaretha in German. And this was very useful in order to understand which articles, how many articles actually link the heat with the health together with the built environment, and at the same time ranking all the climate indicators that are using, that these articles are using in their papers and research, which kind of variables they are considering to understand the sensitivity and the adaptive capacity determinants for the population. And finally, also, which kind of variables related to the indoor characteristic as well as outdoor characteristic are considered in which group and in which categories. Of course, the groups and categories have been decided by me and Margaretha and the other author in order to clarify which variables fall under which groups, of course, based on the literature. It's not something that we decided by ourselves. This article was necessary in order to understand which kind of indicator best represent the social inequalities evaluation in relation to the heat exposure. And thanks to that, we have been able to select specific indicators that you see here in the left table. Related to each category. Therefore, we decided for this second research to divide the subgroups in men and women in order to see the differentiation between these 2 groups. And we classify the time series analysis into specific subcategories, such as, for example, 4 different groups of age, 3 different groups of education, 4 different groups of marital status, and 2 different groups of household occupants, where alone is a person isolated, therefore living alone, while not alone brings +2 onwards. In the results that we achieved here gave us an idea of how the relative risks at the 99 percentile of temperature can vary among all these groups in order to understand also who are the most exposed. And we also have been able to calculate the attributable fraction due to moderate, extreme, and all temperatures. And also the attributable number, who refer to the absolute number in these conditions for all these subgroups. After having done this kind of research, who gave us a prospect of who is more at risk, and we try, of course, to justify with the literature and with the expert on the local scale why this is the relative risk that came out. We decided, together with the researcher from East Global in Barcelona, to take the time series and divide it in several intervals in order to see how each of these subgroups change their relative risks over the years in, let's say, extreme heat in this case, but also extreme cold conditions, because at this point we decided to control also for the cold conditions, since the cold extremes make much more mortality rates instead of cold extremes, due to also influence and other factors. And from this analysis, we understood that actually, in contrast with the insights coming from the Spain research, similar to this, the population of the city of Turin is not adaptive to the impacts of heat. The last article that I want to, let's say, specify insights about relate to the intra-urban patterns of the risks. In order to do so, we decided to apply, as I was mentioning before, the IPCC assessment report, let's say 5 in this case, framework, who refers to hazard, exposure, and vulnerability. The hazard in this case are the indicators related to the heat stress. The exposure in this case is the population over 65 years old, since from the previous analysis it came out clearly how the population over 65-year-olds are the most exposed to the heat in urban context in Italy. In Turin. And finally, the last, let's say, factor it relates to vulnerability, who refers to all the characteristics of the people, but also of the context who surround those people. And we, based on a step-by-step methodology, we integrate all this data. As I was mentioning, for this analysis, we did not use a time series, but we used the last available data at the census tract level, at least for the exposure and vulnerability, to understand the distribution of all these characteristics. Then I'm not going into detail of which kind of indicators we use, because they are a lot, but you can find all the, let's say, insights from this analysis in the article itself that is open access. This permit us to reach a point that you, a map, let's say, that you can see in the bottom right of the slides, where you see red hotspot, and the red hotspot are where the risks coming from this analysis seems to be the highest. So we decided, at this stage, I decided to show you which kind of policy relevance, at least from my point of view, this research have, and which kind of scientific and methodological relevance they have on the other side. When we consider its policy relevance, this research have been useful to understand the hotspot areas, if we can call it like this, the red ones, who also consider the social inequalities across the city, as well as the built environment variables, which contribute to increase the vulnerability of the population living a certain context. And this is in paper 4 and 1. The ranking of the relative risks related to all the subgroups of the population permit to understand which are the most vulnerable for the city of Turin. And also this can be an information to use for doctors, like medical doctors, who have a list of the patients that they can call in order to advise them, let's say, on the fact that Hanitcam is going to occur. And this is for paper 2. Understanding whether the city has actually reduced the heat-related health risks over the years, and this is for paper 2 and 3 actually, and this is a kind of evaluation and monitoring. Therefore, it's also useful to evaluate the effectiveness of the adaptation measures that the city decided to take in the past, if so. When considering the scientific relevance, this is something that I just mentioned, so I'm not going to spend so much time on this, but the line of the research that we decided to undertake is quite strong. In fact, we have a general prospect from the beginning in order to understand which kind of variables count the most and for which reason in relation to the social, economic, and demographic ones, but also health and also the built environment ones. The two, let's say, research in the middle have been useful to understand which kind of quantitative methodology we can use in order to understand, like in a fine way, how the risks distribute across the city and for which reason. And in doing so, we use a really big and rich time series related to different aspects. And the last article was related to the IPCC framework based on not a time series, but a lower amount of data that still are needed to do this kind of analysis, but is more adaptable and flexible as a methodology to be reproduced in other contexts. There are key limitations for this research and that we are aware of. The involvement of stakeholders is not something that we considered in order to run this initial research. The judgment of experts at the local or regional or national scale have been not taken into account. Therefore, for the paper based on the IPCC structure framework, we did not weigh the indicators. And this is, of course, something that could give more power to the outcome coming from the risk assessment analysis in general. And finally, we did use data already existing on the ground coming from the ARPA Piemonte, who is the regional agency for the protection of the environment. And this was related to the distribution of the urban heat island, that is the phenomenon itself. Therefore, the next step that we decided to do, thanks to the one of a project, was to consider open access data available on Copernicus to see how the resolution of the dataset, but as well as which kind of indicators can best fit into the risk assessment framework that I mentioned in the fourth article related to the IPCC structure. So thanks to all the research we run in the last year, we have been able to participate to this amazing project that is called SDGs Eyes project. The aims of this is to strengthen the European capacity to monitor the SDGs based on the Copernicus data by creating also a portfolio of decision-making tools to track SDGs indicators. The City of Turin is a pilot for this project, and it refers to an indicator called SDGs 1330, who refers to the mean deviation surface temperature and relate to the SDGs number 13, climate action. In this project, as I mentioned, that we use open access data, but we also considered the involvement of stakeholders. And with stakeholders, in this case, we refer to health policymakers, urban planner, local authorities, but also other stakeholders who are interested in the process and also in the decision-making tool. So we decided to, based on a performance analysis, to validate which kind of indicators can are best aligned with the heat early warning system at the local scale. This just to give a prospect real with the early warning that already exists on the ground. And we are still building, because the project is going to finish this year, this map that is related to a census tract level, where you can select actually the indicator you want to see, therefore maximum apparent temperature, heat waves, summer days or tropical nights, the distribution of it, and the link with the exposure as well as vulnerability to have a final overview of the risks, also in relation to the specific area you want to analyze. For example, if you click on a specific census tract within a specific district in the blue line or neighborhood, red line, then you have a prospect of how much the different socio-economic and demographic indicators that we decided to consider for this risk assessment weighed on the final risks, and also on how much the different factor of the risks, hazard, exposure, and vulnerability, weighed on the final risks. Having said that, there are few routes of advancement for future research that I want to raise here with you today. The first one is that in order to do the climate assessment and climate profile assessment, we did use open access, data and data set available from CMCC in open access, such as VHR, which has a resolution over Italy of 2.2 kilometers, and some other hotspots in Europe, but also other dataset coming from Copernicus. But we did not have the opportunity yet to integrate this climate assessment analysis with remote sensing analysis using satellite data. Of course, having an integration of the two can provide a sophisticated a quantitative layer of information at a finer scale, and can permit also to have a more clear prospect of how the risks is diversified and how the climate hazard in this case is diversified across the city. Another routes of advancement refer to the integration with insights from the exposed population, but not only from the population in general, particularly regarding the risks perception, because the perception of the risks is something fundamental to take into consideration. Also because often the most exposed are also those who do not feel actually how much they are exposed. So a co-design activities that can be genuine across the time can be very richful to this kind of processes. And this can refer like to the heat risks, but also to other kind of risks, of course, in relation to the climate, but not only. I highlighted here the word genuine because thanks to another project that I was part of called Adaptation Agora, me together with other colleagues in other part of Europe, we have been able to interview some policymakers at the national scale in order to see their perception of co-design. And what came out was very interesting is that actually the co-design, at least in Italy, is something perceived as useful, but the trustness in the process is not so strong, as well as the continuity of the process of involvement is something that is lacking. Therefore, if we do not have resources to have continuity, then the process is losing the power. At the same time, another aspect is that genuine co-design must really take into account the insights coming from this kind of co-design activities. Therefore, it's useful to have them, but of course, if at the end we include this overview and this perception also of the risks into consideration. Finally, the co-design activity also are very useful to increase the awareness of the population, but of the most vulnerable in particular. And it can increase the sense of trustness. And at the same time, as the European Commission stated clearly in the guidelines for stakeholder engagement mission of adaptation, it's easier than if you trust more the process to monitor the process, because it's also an interest of the citizens to monitor if the measures are going in a direction that are agreed. In relation to this, I just want to mention this report published last year. It's called Making Cities Resilient 2030, Flames of Change. And it gives a list of several case studies who are considering the inclusion of communities to take, let's say, decision in relation to heat and also wildfire governance. In this case, highlighted here the case study of Milan, that is quite close from Turin. It's just 1 hour by fast train. In Milan, they decided to use a human-centered planning. In fact, the Milan's Air and Climate Plan, PAC called, integrates climate adaptation and mitigation with human-centered approach. And this, of course, emphasizes a bottom-up approach, but at the same time, they are trying to give a sense of genuinity into the process, involve the citizens from different project-based participation who related to different, let's say, kind of participation, as you can see the bottom part of the slides. But at the same time, they structure a permanent citizens' assembly on climate, and as well as, for example, the city of Bologna. They structure a citizens' assembly of randomly selected individuals who are more informed and involved in PAC implementation, help evaluate and improve climate actions, and propose solutions for consideration by the city. Of course, when we are talking about citizens' assembly, there are different kinds of citizens' assembly. For example, in the case of Bologna, they have a strong experience because they started to build this kind of processes, not just in relation to climate, but in general. And they integrate the point of view citizens who lives within the city of Bologna, but also who leave the city just for work, therefore they are going back and forward, in order to understand their perception and to make them really part of the process. And to do so, they choose the population in a random way, so as to have a sense of the real population, And they, of course, provide them, let's say, a little pay for that in order to be able to attract all kind of the population, and not always the people who are interested in climate that have different, like, specific, let's say, layer of characteristics. The last routes of advancement that I want to mention for future research relate to the integration of this kind of tool with other climate hazards, for example, like flooding and drought or others, but also with the integration of mitigation. And this approach, the integration of mitigation and adaptation point of view into a specific tool and platform, can streamline existing tools and platforms that today start in some contexts to be quite a lot, but at the same time could enhance the co-benefit that exists among different adaptation strategies, but also among mitigation and adaptation. This is, in fact, the case of the last IPCC cycle discussion, where we discussed a lot about which kind of theme and which kind of topic and factor include in the outline on the working group reports, for example, in this case, number 2. And the co-benefits of adaptation and mitigation and the nexus among these two, let's say, approaches to tackle the impacts of climate change have emerged as something fundamental to take the further step. I just want to conclude here with this slide that refers to the concept of transformative change and transformative adaptation. We are nowadays moving from a political point of view, therefore UNFCCC negotiations and discussion, but also from a scientific point of view, therefore IPCC and research on the ground, from the concept of transformative change, who relate to the adjusting system from within, to the concept of transformational adaptation, who refers to the fact that we need to reshape the system from inside in anticipation of climate change impacts. Transformational adaptation is a term that started to be into the UNFCCC decision since, if I'm not wrong, 2 years right now, and is very interesting because means rethinking how systems function beyond incremental change, shifting structure, strategies, and locations, promoting long-term cross-sectoral change with deep social implication, and here the social part is very important, therefore also social inequalities and spatial implication. So this brings to a change of narrative for all the context, the global north countries, but also the global south countries. I had the occasion to follow a side event during the last conference of the parties in Azerbaijan. And it was very interesting because this, let's say, head of a unit of the ASEAN Development Bank state clearly how it's difficult for some country to start to talk about transformation adaptation because this can bring to some layer of difficulties to reach the funds in relation to some grant from Green Climate Fund or others. But at the same time, it's a very huge opportunity because if we start to think about development, also looking at transformational adaptation into some countries, this can, let's say, improve and enhance the process also in terms of time, but also in terms of prevention. In relation to the heat and nexus, there is a specific example into the UNFCCC document related to transformation and adaptation, who state clearly how the health resilience is no longer just a health sector issue, also if we are considering the One Health prospect, but it emerged from urban design, community structure and participation with intersectoral collaboration. With this, I just want to point out that last summer, the different, let's say, scientists coming from all over the world agree on the outline of the special report on climate change and cities of the IPCC. This report is going to be published around March 2027. If you want to see more information, you can scan the QR code that brings you to the page of the special report, and where you can find also the outline, and where all the aspects that we mentioned today in this webinar are actually treated in detail. In here, you can see the reference of this presentation. This is going to be recorded, so you will have available also the video in a second time. Thank you.
Thank you, Marta, and thank you for all those who have dropped their questions and suggestions throughout the Marta's presentation. I just go across some of the questions and suggestions. So there's Madeleine Helmer from the Netherlands indicating menu for health housing habitat, which is and provides the internet address, which is now used by more than 30 municipalities for designing their heat management strategies. And you have referred to transformative transformative policies later. One interesting question which goes in the direction of perhaps of further research comes from Linda, who is asking on how much or whether and how much you did refer to indoor conditions. So the quality of dwellings and whether you see, I think you did not, we're not able to care much for that because of lack of data. So, but please explain better.
Thank you, Margaretha. In relation to this last question, we have been able to include indoor condition just in the review. So we did not have the time to include that kind of information into the real analysis in our case study. And this is a shame because we are sure that considering the indoor condition can be very reachful for this kind of analysis, because most of us spend a lot of time in our home and in our offices. But at the same time, we are not it's not available a data set over the City of Turin, at least yet, but I think it will be difficult to have also in the next year, who can give us this kind of information across the city at the higher resolution, let's say. If I may, I also see in the chat question coming from Zenebe from Africa, who's saying most of
the next one I wanted to propose.
Okay, thank you. If you want to take it, then I can reply afterwards. Okay.
It's okay.
Okay. I think this question is very interesting. In developing countries in Africa, most of the inhabitants live in informal slums. When this combined with climate change, it imposes huge impacts on the health of the inhabitants. What best solution will city administrators should take to improve the situation? This is a very important and strong question. Actually, I had the opportunity to follow a summer school in Copenhagen last summer that was about how to improve the slum condition in a transformative adaptation way, looking also at this risks and this concept in a more resilience point of view. It's not an easy question because it depends on many conditions, but what I can say based on my experience today, that it is important to understand which kind of priority the context under consideration has. So for example, if you're considering a slab with certain characteristic, it is better in order to tackle in a proper manner this kind of characteristic to try to include into the process of the management and of choice at the beginning the expert who can help you most to consider these aspects. And at the same time, based on our previous experience, I will also suggest to include a bunch of citizens who actually live within the slum, because they can have the perception, they can have other point of view that are not aligned with the, let's say, top-down point of view. Therefore, an engagement of these citizens can be very useful, not only to integrate their perception, but also to, as I was mentioning, increase the trustness of the process and increase the awareness of this population living in those areas that are affected by several characteristics. And of course, maybe most of the time, these populations have less access to certain, let's say, education, but also less opportunity to talk about specific aspects. I don't know, Margaretha, if you want to add some more in relation to this very nice question. We cannot hear you.
So nothing to add. Thank you very much. There are some questions on the possibility of matching different spatial resolutions. It goes completely into another direction of the remote sensing data with what you have on land use data. Several questions about that. Do you want to stating that it is the current resolution is perhaps not 2 per 2 kilometers is a bit too coarse to act on urban contexts.
Yes, I agree with this. In our case, we consider the 2.2 climate model open access dataset from CMCC that together with Serra and ERA Land, and there are other 2 datasets available on Copernicus. For example, ERA Land is even characterized by lower resolution, but it's make this kind of tool replicable in terms of climate profile analysis in other contexts. In a city like Turin, the resolution is quite low, but in a city like, for example, Lagos, which is huge, even a resolution of 9 kilometers can be a good start to have. We did not include satellite data with the use of remote sensing because this was a limitation of our study. But I totally agree that the integration of this kind of data into a risk assessment are very useful in order to integrate the perspective, real perspective of the risks. So most of the time what I heard is that in order to intake, when we are talking about the heat nexus at the urban scale, you can consider some specific days in which the heat wave occurs and try to analyze those kind of images in order to see the distribution of the heat across the city. That is also something taken into account into other indicators that we consider, such as greenery or the height of the building, the quantity of impervious surfaces. So if you do so, you have also to pay attention on which indicators to take into account into the risk assessment so as not to duplicate the indicator counting, let's say.
Yeah, thank you. There were several questions about different aspects on what is included in these aggregated indicators, but I think it would be good to consult the single publications for that. A last question is, which I would like to turn to you, is the one: how do decision makers use your data in Turin? The platform is available, isn't it? And it is in the link is visible too.
Let's say that a colleague of mine, Mattia Scala, Alessandro Pugliese, and others are working on it from CMCC, but not only. We run 2, let's say, workshops with key stakeholders, such as stakeholders related to the health sectors, as well as planning, but also citizens in general, so as to include their point of view of the tool at the initial stage. In the first one, we have been able to include insights related to the fact that it was useful for them to have also the visualization of the distribution of districts and health districts and also neighborhoods across the map. And this is why you were seeing a lot of red lines, green lines, and blue lines that you can activate or deactivate it. So as to be able also to download those specific data in relation to a specific health sector, for example. The platform is not still open. It will be open very soon. The idea is to the optimum would be for the decision maker to use it in order to understand in which area to act with priority, but also the information that the tool can give to you are very useful in order to understand which kind of variable influence the most in relation to the final risks. Therefore, also not only where to act with priority, but also a layer of quality. Therefore, we are acting in this specific area with priority, but why? Like what is the reason behind it? So this is also a very important aspect to take into account. And this is also very important, let's say, information that this tool can provide.
Perfect, thank you. To somebody, I erroneously stated that it's already available, but please refer to the recording, which will be available for many of the questions you put. Unfortunately, we're not able to respond to all. The recording will be shared soon on the CMCC website, and on the last page, further to the QR codes you saw throughout the single slides, you will find a list of all publications. For the reminder, please don't hesitate to contact Marta and myself. We will be happy to remain in contact with you and go and proceed on your on the discussion with your starting from your nice suggestions. Thank you. Thank you very much. And hope to see you soon in some other occasion. Goodbye.